Welcome to Ask and Learn.
So for this problem, what we have is y equals x to the sine of x. And whenever we're dealing with these kinds of functions where we have an exponent with the x and the base with the x, we want to implement logarithms, and specifically the natural log. Here's why. If we take the natural log of both sides, we can simplify this by getting rid of the exponent. So now we have a sine x out in front. Then we can take the derivative of this and perform implicit differentiation. So when we take the derivative of this portion right here, we get 1 over y times y prime, and that's going to be equal to, here we'll use what's known as the product rule. You may have already been doing it a lot at this point. So with the product rule, we take the first portion of the product and just keep it there, but we multiply it by the derivative of the second portion. So this portion right here, natural log of x, will give us 1 over x. And then what we have is plus, we keep the natural log of x this time, and then multiply it by the derivative of sine x, which is just cosine x. Now that we've done this, we want to combine all these terms and simplify further. So we'll get the sine of x over x. And then this will just become natural log of x cosine x. And then lastly, what we want to do is multiply the y on both sides. So when we do that, we have y over here, but we know that y is ultimately equal to x to the sine x. So that's going to be our final answer. Notice how we made things a little bit more messy by putting the natural logs in, but ultimately it made things simpler because it allowed us to do product rule rather than having to deal with the exponents, which are much more difficult to differentiate. So that's a helpful technique that you'll use oftentimes whenever you see an exponent with a variable in both the base and the exponent portion.